Hello friends, welcome to CodeChef. This is Suraj, and in this video let's discuss this problem, maximum median matching, from July Lunchtime 2022. Now let's understand the problem statement. So here in this problem it is given that there are total n boys and n girls to attend a dance class where n is an odd number. Okay, and for today's practice session they need to form n boy girl pairs. So the ith boy, it is given that ith boy has a happiness value of AI and ith girl has a happiness value of BI, and a pair consisting of ith boy and jth girl has a happiness value of AI plus BJ. So let's say we have two array A and B. So the ith element of this array A will represent the happiness of ith boy, and the jth element of this array B will represent the happiness of jth girl. And if a boy, let's say if the ith boy, okay, and jth girl are in pair, so the total happiness of this pair will be equal to AI plus BJ. Okay, so now let the happiness value of n pairs be C1, C2 till Cn respectively, and the dance instructor would like if many of the pair have high happiness value and passes this task to us. So we need to find the maximum possible value of median of C, okay, if boy girl pairs are chosen optimally. So here C1 represents, let's say if there is pair P1, okay, this P1 pair can be between any I and any ith and jth boy and girl. Okay, so this C1 is the total happiness of this pair P1, and similarly C2 is the total happiness of pair P2, and like that. So given this array C, okay, C1, C2 till so on till Cn, we need to maximize the median of this array. Now let's see the input and output structure. So here in the input, first of all we'll get total number of test cases. So here this 3 is equals to capital T, that is total number of test case, and then for each test case we will have 3 lines. So here this is the first test case, then this is the second test case, and this is the third test case. And in each test case, in the first line we'll get the value of n. So this is n, here n is equals to 1. Then on the first line of each test case we'll get the array A, and on the second line after this n we'll get array B. So here in this test case, after this n, the first line is this, and then this is the second line, so we got array A and array B. Similarly here this is the second test case, here the value of n is 3, and here this is the array A and this one is array B. And similarly here the value of n is 5, so we got 5 elements in array A and again 5 elements in array B. And let's say we pick any random index here, let's say this one. So the happiness value of this third boy is 93, and similarly the happiness value of this third girl here is 62. And in the output for each and every test case we just need to print the maximum value of median, okay, this median of C which we can get. So here in the first test case it is given that the maximum median which we can get for the first test case is 35, so we print 35, and similarly for second and third test cases. Now let's understand the approach with the help of this third test case. Okay, so here our array A is this, and this is the array B. Okay, so here our C will be simply C will be of total size 5, okay, because here we can form maximum 5 pairs, and pair we can pick one boy from here and any girl from here. So in total we can make such 5 pairs. And as we are asked to maximize the median, so we know that in any array, let's say if this is the array, then its median will lie in between. Okay, if this array is sorted, this is sorted, then its median will lie in between, and we need to maximize this position. So as here we need to work on this median, so the first hint which is coming to my mind is to sort this array A and B, because if we are sorting this array A and B, then we can use them in a specific order such that we get maximum value here. Okay, so first thing is sort A and B. Then after sorting we get multiple options. Okay, so first thing is, let's say if this is an array A, so we can arrange array A in increasing order, and we can arrange array B in increasing order, and we can take 1 to 1 pairing. Okay, this is first option which might come in our mind. Then the second option is we can do A in increasing and other array B in decreasing, and then we can do 1 to 1 pairing. So this is the another approach which we get. If we are sorting the array, then immediately after this, these two ideas immediately should come into our mind. Then from here we should take some observation, and after making some observation, we should conclude rather whatever answer we are getting from both are correct, or we need to do some optimization in order to get the correct answer. So let's see one by one what observations we can make from both of this approach, and let's see how we can get to the correct answer. So here this is array A and this is array B. So here I have sorted this array A in increasing order and also sorted this array B in increasing order. Then here I did 1 to 1 pairing. So here you can see this is array C, and it is simply equal to sum of both the numbers in array A and B. So 5 plus 6 is 11. Similarly 10 plus 26 is 36. So here the observation, let's write it here. So first thing is array A and array B are in increasing order. So we got array C in increasing order. Okay. And then second thing, here a median will surely lie in between. Okay. So this position will always give the median. And the second thing is, now here you can see that the largest number is add up with the largest number of other array. Okay. So the sum will be really large. Okay, and the smallest number of one array is getting added with the smallest number of other array. So the smallest in C will be really small. Okay, so I meant to say is there will be a significant difference between the smallest and the largest number in this array C. Now let's try another approach. So here our array is in increasing order and array B is in decreasing order. Then again we are doing 1 to 1 pairing. So we are adding 4 with 62, we got 66. Similarly 5 with 34, we got 39, and so on. So here now you can see that this array C is not in any particular order. Okay, there is so this array C is neither in increasing or nor in decreasing order. So here in the first case our median was always in center, but here a median can come at any position. Okay, so then what we need to do is we need to sort this array C again, and then we'll get the median. So this is the smallest number, so let's write 1. Then this one here is the second smallest number, and this one is third smallest number. So the median is 39 here. Okay, in this approach we are getting median equal to 39, and here we got median equal to 36. So you can say that clearly the approach 1 was not giving us the correct result, because we got something better in approach 2. Okay, so approach 1 is invalidated here, but here you can do one conclusion, that conclusion 1 is median can be anywhere. Okay, anywhere. So we need to sort first. So this is the observation, and here another observation is the difference between the smallest and the largest number is significantly reduced. So this third point here, difference was there was a significant difference between smallest and the largest, but here difference is reduced. Okay, and here one thing that is coming to my mind is, can we further increase the value of this median? Okay, so here we got 39. So is the answer 39 really? Okay, is it really correct, or we can further increase the value of this answer? So now here there is one more observation which we should do. First of all, let's write this array in order. So it will be 22, then 36, then 39, and then 66, and then 97. Okay, so this is our median. So from this second and from first, there is one thing. Here in the first method, our smallest number is really small. Okay, So we are not utilizing much of the number in this part, okay, in the first half. In the first half, the numbers are really small. But here, as we are doing in the we are adding in the reverse order, so the number is equally spread. Okay, so the idea which is coming to my mind is what here actually we need to maximize only this position. Okay, that is, we need to maximize median. We do not need to maximize this position. Then why to use such a big number to add here? Okay, because here we do not need to maximize the initial position. Okay, we just need to maximize the median. Okay, so there is no need to add the largest number at this position. So what we can do, instead of adding 62 here, we can take this 4 up. Okay, so this entire number will shift down and this 4 will come up. So it will become like this: 4, then 62, then 34, then 26, and then 6. Then again, we do not need to maximize even this position, so there is no point in adding 62 here. So we can again take this number here and move it one step up. So then it will become 4, 6, and then 62, 34, and 26. So here what I have actually did is I've brought this largest number in the position where I might get median. Okay, so I'm not wasting this largest number above. So I'm bringing this largest number here and I'm adding a smallest number with the smallest number of A. Smallest number in B are getting added with smallest number in A. So indirectly here we are saving the largest number from B to add up with the largest numbers available in A. Okay, so with this approach you can think of a hybrid approach of both 1 and 2. So now let's see how this hybrid approach can give us the correct result. We are coming up with this hybrid approach in which we are utilizing the smallest numbers from both array A and B to get the smallest number in initial half. Okay, and then we are saving the largest numbers in both the array to maximize the median, which will come in this part. Okay, so in order to maximize the median, we are saving the largest number to use later. Okay, so what exactly we did is we copied this part here, okay, from first method, and then in the second method this is in increasing order and there this is in decreasing order. So we copied the idea of the second method here. So from here then you can see that the smallest, considering this section only, okay, now consider this section only. So the smallest number in A is getting added with largest number in B. Okay, and then the second smallest is getting added with second largest, and the largest in A is getting added with smallest in B. So this is one of the pattern which we are automatically getting here is here. Okay, now this will give the values as 72, 50, and 119. So you can see that from here we have already concluded that a median can be at any position. So similarly here in this section our median can be at any position. So here our median which we are getting is equals to 50, which is surely larger than what we were getting here, that is equals to 39. Okay, so it is greater. So we can clearly say that our second method was also not giving us the correct result and first one was surely not giving us the correct result. But here we need to justify if this is really the largest median which we can get. Okay, so what you might think is can we increase the value of this 50? Okay, you might think like that. So in order to increase the value of 50, what we can do, we can replace this 16 by 93. Okay, or we can replace this 62 by 34. So in both the ways we will increase the value of this 50. But another thing is, if we increase this value and then this value here will significantly decrease because this is the largest number. And again, if we are swapping with this, then the value of this 119 will significantly decrease. So what will happen is this value will increase, but as this is gonna be decreased, so this will become our new median. Okay, so indirectly here, if A is in increasing, okay, this half of A is increasing and this half of B is in decreasing. So this will give us the optimal solution. Now let's see how we can implement our approach. Okay, so we are given array A and array B. So first thing we do is sort in increasing order. Okay, so we'll get A1, A2, A3, and in this order till AN. Okay, after sorting, and similarly B1, B2, B3, and so on till Bn. Okay, so first, then what we'll do, we'll ignore the half region. Okay, because from here we'll get the minimum values. Okay, so we are saving our largest value to be utilized in the another half, so we will ignore this part. Okay, so here we have total n elements. Okay, so let's say this, if this is total n. Okay, and this n is odd, so let's say this n is odd, and here this will be our median. Okay, this is 1. Okay, and so the total numbers in this part will be equals to n minus 1. Okay, I'm subtracting this 1 from overall n minus 1. So n minus 1 will be, if this is one element here, then combining this both halves will get n minus 1 on in total on both the half. So in each half we'll get n minus 1 divided by 2 elements. Okay, so as our array is zero based indexing, so the index of this middle region will be simply equal to n minus 1 divided by 2. Okay, so what we will do is we have this array A, we have array A in increasing order, and we have array B in also in increasing order. So we'll get the half part, index of this half part. So that will be our start position. So I will mark this start as n minus 1 divided by 2. Okay, this will be our starting position. Then we also need to find the end position, where in within which range we should use the numbers. So our end here is simply n minus 1. Then what we'll do, we'll pair the starting position of this A with the ending position in B, and then the next will be paired with this, and then the next will be paired with this, and likewise. Okay, so indirectly what we'll do, we'll increment this and we'll decrement this part. So let's say we iterate from, let's say I is equals to start, we iterate from start till end of this array, that will be simply n minus 1. Okay, and we add ai, that is ith character after the start, with b end, and after this what we'll do, we'll increment this I, as we are in for loop, so we'll increment this I, and also we'll decrement this end. So this I is incremented, so what will happen is, in A will move one step ahead, and in B will move one step back. Okay, so this way we'll pair up the starting and the end like this order. Okay, and then this is the happiness value. Okay, and our median will be simply the minimum of whatever happiness we are getting in this region. So we need to take let's say we initialize our answer here, median initially equal to some large number, let's say infinity. So then what we'll do is, we'll take median equal to minimum of this result comma whatever the previously we have got the result. Okay, so a previous result or the current one, we'll take the minimum of it, so we'll get the median. So in short, after this loop, we'll get whatever the smallest happiness value we are getting in this region, and that smallest happiness value after sorting will come at the position where our median should be there. So indirectly our median will be simply the smallest value of C which we are getting in this region. So that will be saved in this variable here after this loop, which we can directly print. So I hope you understood the logic. Now let's see the implementation in C++ and Python. I hope you understood logic to this problem, but still if you have any doubt, now you can use this new feature in CodeChef, that is CodeChef's doubt support. So let me just show you how you can use this new feature. So let's say you go to this practice section, and let's say I pick any problem. So let me pick this age limit problem. Then here in this problem, let's say I'm stuck and I'm unable to understand this problem, or you may get any confusion. So what you can do here is, you can go to this ask a doubt section, and here you can chat with our experts. So let me start this new chat, and here I'll ask a simple question. So let me ask. So here you can see that my doubt is answered, and similarly you can also ask your doubts in the doubt support and get the answers quickly. So this doubt support will be available 24/7. So you can ask any doubt regarding this problem, and the experts will be there to answer your questions. So here is the C++ implementation. So first of all, I'm accepting T, the total number of test cases. Then I'm calling solution function for each and every test case. And here in the solution function, first of all, I'm accepting the value of n. Then here I'm accepting the array A and array B. Then here I'm sorting both the array. And then here I've calculated the start and the end position. And then I've initialized median with the int max, that is the maximum value integer can hold. And then I'm iterating from I equal to start till I less than n. And I'll take the minimum of whatever the previous result I have got and the current happiness value of the pair which we are getting. Okay, and then I'll decrement the value of end n, and this I will be incremented in the for loop itself. So after this for loop, our answer will be stored in this variable median, which we can directly print. Here is the similar implementation in Python. So first of all, I'm accepting T, the total number of test cases. Then I'm calling solution function for each and every test case. And here in the solution function, I'm accepting the value of n, then array A and B, and then here I have sorted both the arrays, array A and array B. Then I have calculated the value of the start and the end. Here I'm using double divide to get the integer value instead of floating point. Okay, so then I have initialized this median with some large value. Okay, here the maximum value which we can get is up to 2 multiplied by 10 to power 9, because the maximum value of A and B are itself up to 10 to power 9. Okay, so this is the 10 to power 18 which we can never get. So this is same as infinity. And then I'm iterating from I equal to start till less than n, and I will take a median as minimum of whatever our previous result was and the current and the happiness of our current pair. Okay, and then I'll decrement our end by 1. So we are moving one step back in B, and this I will be incremented in this for loop itself. So we are moving one step ahead in A. So after this for loop, our answer will be stored in this variable, which we can directly print. So I hope you understood the logic and its implementation in both C++ and Python. In case you have any doubt, feel free to write in the comments. So let's meet in another video. Thank you so much.